Hi friends, so now we will see bivariate analysis, which is a part of EDA, right? So in this tutorial we will see bivariate analysis and pandas profiling, how we do that. So what basically bivariate analysis is, through bivariate analysis we try to analyze two variables simultaneously, right? As by the name itself suggests, bi, that means two. So as opposed to univariate analysis, where we check the characteristics of a single variable, in bivariate analysis we try to determine if there is any relationship between two variables, right? So there are essentially three major scenarios that we will come across when we perform bivariate analysis, that are both variable of interest are qualitative. One variables is the qualitative and the other is quantitative, right? And both variables are quantitative. So these are three different cases with our bivariate analysis. So for the purpose of the exercise, we will explore most popular technique to perform bivariate analysis, right? So let's start. First, what happens if we may have certain no scenarios, like there could be numerical versus numerical, where we need to have scatter plot, line, heat map, joint plot, right? If there is categorical versus numerical, then we plot bar chart, violin plot, categorical box plot, swan plot, right? And the last but not the least is two categorical variable, where we try to frame that in bar chart, grouped bar chart and point plot, right? So let's start with the case study, where our aim is to explore the data of suicide rates, right? And let's start using these all those above technique, right, for this particular data set, and that will be using a suicide rate of 1985 to 2016, right? So let's start with loading the libraries, right? Yeah, in the last video I think there was some friends who asked me that how I styled these fonts. So this is nothing but as HTML render page, so we can put all the HTML tag inside our Jupyter notebook to make it look and feel better. Okay, so this is NumPy that we'll use, Pandas, Matplotlib and Seaborn. Okay, and let's start with importing the dataset, that is master.csv, which I'll be providing in the description as well. And this is how our data looks like, where we have country, year, sex, age, suicide number, population, suicides. So this is the rate, and so on so forth. The generation, what about the generation is, if we check the 5 point summary, so again we are using describe function to get the summary of the data. So you can see that the count, mean, standard deviation of let's say population 2.78, and the quartile ranges, right, and the quantile ranges, right, and the max here. Now if we check the column, so again all these column that we can get in a single line, that is by using index data.column. Okay, now checking the shape of data, again the shape is row versus column, and if we count the values, so in this data frame there are 6 object, 4 integer, 2 float types, right? The data types of all those columns, or we can say attributes. Now if we check the data set information, so again by using info function we can get certain information about our data, whether how many non-null values are there, what is the data type of them, right, the memory uses of that particular data set. Let's start with checking the missing values in the data. Okay, so again we are making a small function here, where in that function we are totaling the null values, right? So from is null function we will get the null values, we are summing the null values and sorting them in descending order. Then we are also getting percent, right, by getting the sum and dividing them, but by number of is null values, again sorting that. Okay, and At the last, we are getting the missing data by putting the above two together, that is total and percentage, right? So we are concatenating them and getting the total and percentage, and this is returning the new data frame. So here we are passing our actual data, and in return here you can see what we are getting is the total and the percentage, how many missing data is there. Okay, so again you can see that in the data we have these particular columns, and we are telling that just describe a 5-point summary for this particular column, or we can say descriptive stats for these continuous columns, right? So here you can see that we also getting the frequency table of age. So one way table, that is we are making a cross tab, okay, with our data age and column is count. All right, so it will count the values of all those ages, like 15 to 14 24 years. There are a total 4642 columns, or we can say the values. All right, now if we start with plotting the plot, so let's start with plotting bar plot that check number of suicide by top country. So this is an example of numerical versus categorical, right? So here again by grouping we are passing country, suicide number, summing the value, resetting index. All right, and then we are telling that we just need till 10, that means last 10 values, and just plot a bar. So where x-axis will be our country, y-axis is suicide rate, and this is the fixed size. So here you can see if we check the suicides number in Russian Federation, so this is the highest that is being measured, right? So here you can see followed by the US and Japan. Then Russia, the US and Japan have exponentially high counts of suicide compared to other in the plot. That's fair enough. Now let's plot a bar to check the number of suicide by bottom countries, right? So here again we are checking with the head this time, all right, with the same thing. So if we check the head, so here you can see that in Kiribati there is the highest number that has been reported. Then Cabo Verde, that is second highest, followed by Grenada. So let's plot for number of suicide versus ages. So what we will do is again setting the figure size here, then we are calling the bar plot for ages and suicide, right, with our data. And here our platy is just muted. So here you can see that how it is colored with different colors, right? So if we check the ages group of 35 to 40 54, so this is reported the highest suicide number. If we check the bar plot number of suicide versus sex, so you can see that we are also passing gender here and the suicide number. So if we get that, so for male the suicide rate is very high, right, as compared to female. So let's plot the bar plot of suicide versus generation, again passing generation and suicide, and in our data. So here you can see that this is our generation for x-axis and suicide number for y-axis. So if we check for boomers, so for boomers it is reported very high, right? And the lowest is just a generation Z. So next thing is to plot scattered plot for number of suicide versus population. So if we plot that scatter plot using the Seaborn's scatter plot, passing the population and suicide number, right? So here you can see that scatter plot is also denoting the different suicide numbers, right? So from 0 you can see that up to it is telling 24,000. okay, so this is how the rate look like with population. Here what we are doing is we are trying to plot a regression plot with a scatter plot and the generation line will be here. So here you can see that this is nothing but this regression plot, right? So we just call rig plot, okay, passing population and suicide. So it will plot a scatter plot with that regression line. Now we are simply trying to plot a line plot with the population and suicide number again. So here you can see that how the line that got increased with the population greater than 25,000. So this is a massive, we can say, uh, increase in the population with suicide. So let's plot a scatter plot for the number of suicide with 100,000 population versus GDP per capita. All right. So we are getting with GBT per capita with suicide rate. All right. So this will give the scatter plot for that. So here you can see that again, if the GDP per capita is around 20,000, so it is reported highly around here. So again, looks like higher suicide rates are a bit more prevalent in countries with higher GDP, right? And however, it doesn't look like there any significant correlation between the two. So correlation among pair of continuous variables. So now we are getting the heat map here. Okay, so here you can see that with line width 5.5, and we are also telling that just return me value up to one decimal or one floating point. So here you can see that what it is telling, instead of doing a simple DF correlation, we can use the heat map when there are large number of variables, right? So the color helps with picking out the most correlated easily. And in the our case, we don't have a lot of variables. The plot is just for demonstration. So the darker the color means the higher the correlation is. So here you can see that 0.8, 0.8, right? 0.6 will definitely be higher than 0.3, or we can say 0.2. So the darker the color is, the higher the correlation. None of the attributes seems to have correlation of real significance, okay, and some obvious correlation are that in a large population, okay, so it is likely the number of suicide will be more in those cases. Last point, it is telling that Human Development Index GDP per capita is the only pair with most correlation, right? GDP per capita. So here 0.8 with the Human Development Index. Okay. Next thing, it is asking that bar plot to check number of suicide by sex and age. Three variables used to generate a single plot. Okay, so this is an example of numerical and two categorical variables. So here you can see again we are getting the bar plot where we are passing x as sex and y as suicide rate. So here you can see that the different color for male, you can see that the 15-24 years is the bluish, and the reddish for 35 to 54, similarly with the female as well. Now next thing, it is asking but to bar plot for check the number of suicide by sex and generation. So three variable used to generate a single plot. Again it is saying 3, so we are passing sex as x, suicide number as y, and generation as u. So U as a generation, so you can see that for male generation the boomers is highest and the female is the boomers is highest again. So suicide in males, apart from being higher, has a slight variation in distribution across generation compared to suicide in female. Okay, that I have that I have told you earlier. And in case of male generation, X has higher suicide numbers compared to GI generation, but in case of female it is opposite, that is the suicide rate. Now checking the number of suicide country versus sex. So again we are defining number of suicide by country and sex here, right? So you can see that the number of suicide and country with sex, and then we are trying to sorting the order of these value, let's say in descending order, right? So ascending is false here, and what we are getting is here the top 10 countries in terms of suicide. All right, so this will plot one bar plot with the title count of suicide for 31 years, right? So here we are passing values in the bar plot, x value, y, u, and again platy. So here you can see that this time we have the country of society is here, and the count of suicide for 31 years. So again the high reported is male for Russian Federation, right? Then followed by US and Japan, and that is for male. Again, if we talk about female, that the female is in Japan, followed by RF and US. So Japan has the higher proportion of female suicide compared to the countries that overall suicide rate even more higher. Okay, and now it is asking average number of suicide across each generation for a given gender along with the confidence interval. So point plot, it is also telling that. So if we get that with point plot, again passing the excess generation suicide number as y, and u is here, and data. So here you can see that how the point plot has been generated, and these are the points that we can say for generation x it is around 390 we can say, and for female it is 100, right? So similarly go with boomers, which is reported highly for male and female both. So the graph tells us the average suicide along with the confidence interval, right? And the suicide among female in generation don't seem to be fluctuating a lot. So average suicide of generation Z are almost equally distributed across genders. Now it is asking to distribution of population across each generation, and this time we need to plot the Boolean plot. So with the Boolean plot, because we need a distribution population across each generation. So again x is having a generation and y is having population. So for all those, if we get the Boolean plot, so you can see that again boomers it is reported highly, right? And then for generation x, so the plot is similar to box plot, but here we get a density function, right? So distribution of population across every generation is highly skewed. So potential of lot of outliers. Try it yourself, go ahead and check if there really are a lot of outlier population across each generation. So in that case, we also suggest you to, you can use the box plot here. Now checking trend with the temporal data. So what it is asking that the temporal data is nothing but the data that represent a state in time, right? As it is also initiating here, and such as the land use pattern of Hong Kong in the particular year, or total rainfall in a particular city in particular year. Or we can say the temporal data is collected to analyze weather pattern and other environmental variable like monitor traffic condition, study demographic trends, and so on and so forth. So now in this case we are checking pattern using trend plot, right? Suicide rate versus years. So we have given years and suicide number, so we can get that plot for trend. So this is nothing but the trend plot. So this is how it looks like. Now changing the using trend plot, this population versus year. So we are passing both thing, right? So this is with respect to population and year this time. So you can see that here we have year, and for y we have the population. So at a particular time, let's say in 2014 or in between 2014 and 15, the rate started getting fall down. Now checking pattern using trend plot for suicides per 100,000 population versus years. So for that you can again see that how the trend go for that particular case. Now the second thing with now the second main thing of our topic comes is the pandas profiling with IPL data. So basically, what the panda profile does is, so it generates profile report from the panda data frame, right? So we use panda profiling, right? So that basically extend the panda data frame with the profile report for our quick analysis. So here we can install pandas profiling, then importing sys, right? And this time, so here we can install this pandas profiling by this particular step. So we import sys, and from this sys executable we import the pandas profiling, right? So it will install that in my local machine. That we are also installing pandas profiling using pip, so we can also get that, right? Now next thing, it is telling that import pandas profiling. So now to simply import that, we are using import, and the data csv that we have is match data, that has many useful functionality, but the best one is to generate eda report. So how we can get that eda report? Here you can see that the pandas profiling will return the detailed report of that particular data set. So we are just passing the df here. So you can see that the overview is here: number of variable, number of observation, total missing values, size, average. More thing, there are variable types. Warning is also there, like is highly the particular season is highly correlated with id, this one that is rejected. The number of missing values, warnings are there, so on and so forth. You will get a lots of message here. Now if we talk about variables, so id numeric, so this is the distinct or we can say summaries that we are getting here. Number of unique missing values, infinite values, right, with the plot as well. So we can also get the toggle detail here. So you can see that the season is highly correlated with this, and the city, that is categorical. So it has also defined that the date, team 1, team 2, toss winner. So every description for each attribute will be given here, just with the profile report. So here you can see the correlation with Pearson, you will get here, right? With Spearman you will also get that. And this is the sample, or we can say why we use head of the panda data frame. So basically that just helpful to generate the EDA report, right? Here we can also get that particular file in our HTML format. So just we need to get the pandas profiling dot profiler report df to file. So it will generate one HTML file for that. And step ahead is, you can also try yourself by creating pandas profile report for the inning data.csv in IPL data that I have provided earlier, right? So let's uh, try that, and let me know if you find any problem in that.